Hey guys, welcome to day 6 of 100 Days of Code. And well done for making it this far. So today we're going to talk about code blocks and indentation, as well as functions, and also a different flavor from the for loops that we saw yesterday. Today we're going to talk about while loops as well. And to learn all of these things, we're going to use the help of something that's very similar to Karel the robot. And this is something I used when I first learnt how to code. And it's one of my favorite tools for learning programming, especially as we get into more difficult concepts like functions and while loops, etc. And by the end of the day, we're going to be writing the code that's required to instruct our little robot to be able to complete any randomly generated maze. So that's the goal. And if you head over to the next lesson, let's get started and let's start learning about some of these things. The first concept I want to introduce you to is something called functions. And just as we perform many different functions, it could be mother, father, son, daughter, we can also get our code to perform different pieces of functionality. Now, if we think back, we've actually already come across functions, and I've been referring to them every time we've needed to use one. If you take a look at this link in the course resources, which takes you to the Python documentation, then you can see that Python has a whole bunch of built-in functions that we've been using. For example, the len function, which gives us the number of items in a collection, or the int function, which turns something into an integer, or the print function, the range function, and other ones that we haven't seen yet. If you head over to the Day-06 starting replit and go ahead and fork a copy of it, then we can start typing one of the functions that we've been using a lot, which is the print function. And the reason why we know it's a function is because it's the name of a function followed by a set of parentheses. Now we know that if we put something inside these parentheses, say for example hello, then when I run the code, whatever is inside those parentheses will get outputted over here in the console. Now all the functions work pretty much the same. So if I wanted to use the len function to see, well, how many characters are there in this word hello, I again put my hello inside the parentheses, and because of the parentheses, we know that this is a function, and then I can save the outcome of this length function to a variable. Say, let's call it number of characters, numchar, and then I can go ahead and print it in order to view it inside the console. So let's print the num underscore char, and now you can see that this len function gets to work, calculates the number of characters, it's 5, and then it gets printed. So all of this functionality has been achieved by these built-in functions from Python, like print and len. Now, what if we wanted to make our own functions? How would we do that? Well, if we want to make our own function, we first start out with a keyword, which is called def. And this is because we're creating or defining our function. Now, after the def keyword, we can give our function a name. And I'm just going to call it my function. Now, the thing that differentiates a function from a variable, however, is the parentheses. So after the name comes the parentheses, and now the final thing, the finishing touch to our function definition, is a colon, because that says everything that comes after that line and is indented belongs with the function. Let's make a really simple function that just has 2 lines of code. Maybe it prints hello, and then it prints bye. So now I've created my function. I've placed the lines of code that are associated with this function all indented after the definition. But notice how if I go ahead and run my code, actually nothing will happen. And the reason is because we haven't yet executed the function. Now we can define lots and lots of functions ahead of time, and it's only when we actually need it do we go ahead and trigger it. And to trigger it, or in programming lingo, we would say to call the function, all we have to do is type the name of the function, which is my function, and then to add the parentheses and any necessary inputs. In our case, our function doesn't require any inputs, so we can leave the parentheses blank again. And now if I go ahead and run my code once more, then you'll see that by the time the computer reaches line 5, it's going to search for this thing called my function. It sees that it was defined right here on line 1, and it goes through all of the content and executes them in turn, line by line. And that's why we get hello and bye being printed here. So just to recap, this is how we create a function in Python. There's 2 steps to it. The first step is to actually define the function, to specify what it should do. And we do that by first using the def keyword, and then we give our function a name. So for example, in this case, I called it my function. And then comes a set of parentheses and a colon. And then after that, we get to put the lines of code which will be included in this function. And remember that these lines of code which goes into the function, which will be carried out when this function is triggered, must be indented like this. So once you've defined the function, you've created the recipe, the next step is to actually use it, which in programming lingo, we would say calling the function. And we call the function just by specifying the name and a set of parentheses. And once the computer sees this line of code, it'll know to go and carry out all the instructions inside where we defined our function. And to learn about functions, I'm going to introduce you to something that's very similar to Karel the robot. The robot is going to be something that is just going to perform the tasks that we want it to, and no more and no less. So for example, if we wanted a robot to go to the store and pick up some milk for us, we can't simply just tell it, oh yeah, just go and buy some milk, because it won't know how to do that unless we give it specific instructions, such as leave the house, walk 2 blocks to the right, walk 4 blocks back, and then 2 blocks to the right. When you go to the store, give them some money, and then take the milk and come back. We have to program each and every step. But say if this functionality of getting the robot to go and pick up some milk for us is needed every single day, then we have to write out all of those instructions day after day, day after day. And at some point, our fingers are going to hurt, right? We're typing so much code that's repeated because we don't have a way of bundling all those instructions together. And that's where functions come in. Functions will give us a way of referring to all those instructions at the same time. That way, we can give our robot a single instruction and it will carry out all of those little steps for us and get us some milk. Now, to try this out yourself, I want you to head over to the course resources and click on the link that takes you to Reborg's World. Now, Reborg's World is very similar to Karel the robot that I showed you earlier on, but it allows us to write Python code. And it's very easy to get started. Now, we've got this area here, which we're going to use to write our Python code. And then once we're done, we can click on play to run the Python code and see the instructions carried out by our robot. If you click on Reborg's keyboard, you can see all of the functions that we can use to command our robot, like move or turn left or build a wall, etc. Let's see if we go ahead and run this line of code here, move, what happens. When I click play, you can see that our robot moves forward in the direction that it's facing by 1 step. So if we wanted it to move, say for example, 3 steps, all we have to do is to call the move function 3 times. Now let's reset by clicking the return button to return our robot back to the starting position. Now let's click play again in order for our robot to carry out the new instructions. Notice how all the instructions were carried out very quickly. To execute each instruction 1 step at a time, line by line, we can use this step through button. This button allows us to see how each instruction is executed. And after each instruction, it pauses and highlights the next instruction. This is very helpful for debugging. So notice how we're highlighting line 2. So if I click on step again, it's going to carry out that function, and then it's going to carry out line 3, and finally it reaches the end, and that's the end of our code. Now, in addition, we can use some of the other commands in the keyboard. For example, turn left. If I decide to say move 3 times and then turn left, and then maybe move 3 times again, can you predict which square the robot is going to end up in? Are you ready? Let's go ahead and run the code. There we go. We end up on the square 4, 4. It moves 3 forwards, turns left, and then moves 3 steps again, because that's what we told it to do with our Python code. So now here's a question. If you take a look inside the set of commands, you'll notice that there is move and there is turn left, but there is no turn right and there is no turn around. So how could we use a function to create those commands? Because of course we could just simply write turn left and then turn left again, and this would effectively turn the robot around, right? But if we want to do that many times, say for example, if we wanted to go to 3, turn around, go back to 1, turn around, go back to 3, then we would have to write code that looks a bit like this. We would have to say move 2 times to get to square 3, turn left, and then move 2 times again to get to 1, and then turn left again in order to turn around. This is all the code we would have to write to achieve this kind of effect. But instead of all of this, we could just define a new function. So we use the def keyword to say that this code is defining a new function called turn around. And this function is simply going to be turn left twice. And remember, all the code that's going to go inside the function has to be indented. And now, instead of writing turn left, we can simplify our code by telling it to call the function turn around. And we can do that here, and we can do that here. So now, when we run the code, you'll see that it does exactly the same thing as before, but this time we've cut down 2 lines of code. So instead of 8 lines of code for our instructions, we only now need 6 lines. And you can see that the more that you need to use this function, the more typing it will save you. But more important than reducing the number of lines of code is that our code has also become a lot more readable. So the turnaround function is much more clear than having turn left twice. Now let's see what happens when we use the step through button. Look closely at how each line in our code is executed. So now we're going to carry out the move by 1, and now it's going to call turn around, that function. And it jumps over to find this function and carries out the code inside, in turn, from the top to the bottom. So turn left, and now once that function's done, it goes back to where it was before and continues running. Move, and then turn around again. So here's your challenge. Try and create a separate function that turns our robot to the right. Pause the video, head over to the course resources, and click on the link that takes you to Reborg's world, and then go ahead and create your own function called turn right. Alright, so this should be pretty simple because all we have to do is to define a new function called turn right. And this function is going to simply be turn left 3 times. Because turning left 3 times is going to effectively turn our robot right. So even though we only have this one way of turning our robot, we can define our own functions to give it many other commands that it could use. So now, using this turn right function, see if you can write some code that makes our robot draw a little square going from here to here, then to here, and back to the beginning. Once you're done and you hit play, this is what should happen. So pause the video now and see if you can complete that challenge. Alright, so let's go from the beginning. We start out facing right at the position 1, 1. In order to draw the square starting from this way, we have to first turn left. And then we have to move one step, and that should take us to here. And now we have to turn right, move one more step, turn right again, move one more step, and finally turn right for the last time and move one more step. So using our awesome function means that we don't have to write out turn left 3 times each time we need to turn right. So our code can just be 8 lines long instead of 14 lines long. And we're using our function to cut down on a lot of typing. But not only are there fewer lines of code, look at how much more readable our code has become thanks to our turn right function. It's now so much easier to read, turn right, and understand what it needs to do rather than seeing turn left 3 times in the code. So now it's easier to read and it's easier to follow the logic in our code. In the next lesson, I've got a challenge for you. Head over there and apply what you've learned about functions to try and solve it. I'll see you there. Alright, so now that you've learned about functions, I have a coding challenge for you. If you head over to this link, which is in the course resources, and head over to this challenge, which is called Hurdle 1. The idea is that we've got a robot here, which needs to do a number of hurdles to jump over each of these barriers to get to the final goal here. Now, you need to use your knowledge of functions as well as some of the things you've learned before, such as the for loop or the range function, to be able to achieve this. Now remember that you can tell the robot to move by typing move parentheses, and when that's run, it will move by 1 space. And you can also use, say, turn left to get the robot to turn left. And in this case, when I run the code, it's going to move 1 space and face to the left. In order to complete this entire challenge, you can see there's a number of steps that the robot has to go through before it can get to this final goal. And if you were to write out each of these steps, like I have done here, one after the other, it would take many, many tens of lines of code. And that's not what we're about. We're programmers, so we're born to be lazy. Try and see if you can minimize the number of lines of code while still keeping your code readable and understandable by somebody else, and be able to get your robot to complete these instructions and take the robot to the final goalpost. And once you've completed the challenge successfully, you should get a green pop-up that says you're at the correct X and Y position. So pause the video now, head over to this link, and give this challenge a go. Alright, so how did you get on with this challenge? How many lines of code did it take you to tell this robot to get to the goal? Alright, let's have a think about how we might tackle this. We know that out of the things that we can tell the robot to do, the most useful things are to move and to turn left. But because the robot doesn't have a built-in turn right function, then we have to define that ourselves. And the reason why we need to do that is because you can see at several points during the hurdle, we'll have to turn right. For example, when the robot is here at 2, 2, it will have to turn right and then move, and then turn right again and then move. So let's create a new function called turn right. So we start out with the def keyword and then give our function a name, which is going to be turn right. And then we add the parentheses with nothing inside because we're not passing any inputs to this function. We're just going to use this function as a way of defining turn left 3 times. So when you turn left 3 times, of course, you turn right. And now we have the ability to turn right. So notice how this is the code block for our turn right function, and it ends at the last line which is indented, which is line 4. So every subsequent line which starts at the very beginning of the code file next to the left margin is outside this code block, and it will act independently. So in fact, the first line of code that actually runs in our file is going to be this line 6. And you can see that when I press run, you can see that's the first thing that gets highlighted. And if I go through this stepwise, you can see the first line is going to be line 6, and it tells the computer to go and find this function called turn right. So if I skip to the next step, it's found that, and it's going to start going through lines 2, 3, and 4, turning our robot 3 times until it has turned right. Now that we have the ability to turn right, let's have a think about how we might be able to get our robot to make one jump. Let's see. The first thing we'd probably want our robot to do is to move forwards by 1 step, which should take it here. And then the next thing we want it to do is to turn left so that it faces the top. And once it's in this position, then we want to get it to move forwards 1 step, and then we'll probably want it to turn right. Now, notice how I'm actually testing my code at pretty much every other line that I write. And this means that you don't end up in a situation where you get to the end and you've written lots and lots of lines of code and it doesn't work. In which case you have to comb through all of the code you've written and find out where the problem is. So in this case, we've only got 4 lines and we've been testing it stepwise. So we can see that we're on track and our robot is now turned to the right, ready to move 1 more step. And then once it gets to here, we have to turn right again and move 1 more step. And now it should end up here, but let's just check it out. So our robot turns left, turns right again, and it ends up here facing the bottom. So the final thing we need to do is to get it to turn left once more, so that it will face the forward direction. So once you've confirmed that your code is working, then you should really think about what is the next step, because we've managed to make 1 hurdle. And notice how when we're at this position, 3, 1, this particular square, it's almost the same as if we were at 1, 1, because we have to move 1 step again, turn left, move, turn right, move, turn right, move, turn left. So it's basically repeating all of these instructions. Rather than executing these instructions 6 times, because there are 6 hurdles. So if I go back and I start, then you'll see that this code actually will complete the challenge. It says, I'm done, and we're at the correct position. But notice how many lines of code we've got. We've got something like 58 lines of code. I know I've left some spaces in there so that you can see which parts are repeating, but still, that's a massive amount of code for something very simple. Now we know that we can use functions to package a set of instructions together under 1 name, just like what we've done here with the turn right. We packaged the 3 lines of code, turn left, turn left, turn left, into a single function called turn right, so that when we need that functionality, all we need to do is just to call the function and add the parentheses at the end. So we can do exactly the same thing with this set of instructions, which basically gets our robot to perform a single jump. So let's create a def and let's call this function jump. And then let's add the parentheses and the colon. And very importantly, all of these lines of code must be indented. So to indent a whole block of code together, you hold down the command key and click the left square bracket or the right square bracket. On Windows, it's holding down the control key and again the left square bracket or the right square bracket. So now this basically says that all of these instructions live inside this block of code called jump. And when we call jump, then it will carry out all of these lines of code. So now what we could do to complete the challenge is to simply call this function jump 6 times. And so now we could again solve this entire problem using just 21 lines of code. And we managed to complete this challenge using 2 functions that have repeated instructions and then calling the jump function 6 times. But because we've learned about loops and the range function, we know that we can actually cut this down even shorter. So instead of calling jump 6 times, we could actually write a for loop that loops through and calls this jump function 6 times. We could say something like for step in, and remember that these 2 keywords come from the for in loop and they always have to stay the same. And then after the in keyword, we define the rules for how many times we want our loop to repeat. In my case, I'm going to use a range function, and I'm going to say from 0 to 6, but not including 6. So in this case, it will be 0, 1, 2, 3, 4, 5. So that's actually going to happen 6 times. And now I'm going to add the colon, and finally inside this for loop, I'm going to call jump just once. Now watch what happens. First, it starts off at the for loop, it calls jump, and it goes through this once, and then it comes back, loops again, calls it the next time, and then again, the 3rd time in the loop, 4th time in the loop, 5th time in the loop, and 6th time in the loop. How far did you manage to get? Did you get stuck on this section where we needed to create the for loop? Well, in that case, I recommend going back to the lesson where we covered for loops and reviewing the for loop and the range function in detail before you come back and try to solve this challenge again. It's really, really important at this stage that you've understood and you've mastered some of these ideas, because we're going to be using them more and more in the future. Really make sure that you've understood things before you keep going. In previous lessons, I've already mentioned how important it is in Python to be aware of your indentation. So we know that when we create a function like this, that every line that comes after this definition that is indented is going to be inside this function. So by indented, I mean it's shifted to the right by 4 spaces, like this. So if you imagine each dot as a space, then this is a single block of code. And if we want to continue adding to this block of code inside my function, then we would continue adding lines of code which are indented. So you have to almost visualize for yourself this invisible line around these blocks of code which are indented. Now, if my code was written like this, on the other hand, then the block of code is in fact only this part. And this print statement will not get triggered when this function gets triggered, because it's independent from this function, because it's not indented. Now, a simple way I like to think about this kind of indentation is kind of like the file structure you see when you go into Finder on the Mac or when you go into Explorer on Windows. If we have a function, it's kind of like a folder, and anything that goes inside the function, for example, if I throw this file inside the function, then you notice that it gets indented, right? And this way it shows to you very, very clearly that these 2 files, print hello and print world, are living inside this folder, my function. And this is the equivalent of this code. We have this folder, say my function, and it contains these 2 lines of code. Now, on the other hand, if I take this print world and I put it outside of the function folder, then you can see that this is completely independent from that folder, and it's now indented at the same level as the function. So this is the equivalent of this code, where we've got this print hello being inside the my function, and this print world being outside and at the same indentation level as this function definition. Now the indentation gets a little bit more complicated when we have other blocks of code. So for example, the if, elif, else statements, they have blocks of code which need to be indented to be inside the block. For loops need to be indented to be inside the loop. And it's very important that you get used to looking at blocks of code like this. So for example, if we were to expand our simple my function and add a whole bunch of code into it, then we would have to indent all of those lines of code by 4 spaces, represented by the 4 dots here. Now, if we wanted to have another block of code inside this if statement, then this line has to be indented a further 4 spaces. So this is the function block, this is the if block, this is the elif block, and you have to be able to see all of this while just looking at the indentation. If we wanted to represent this, then it's almost like creating a new folder. Let's call it the if sky is equal to clear. And this if block goes inside my function, so it's indented. Now, if I wanted to have a print statement, let's call it print blue, inside this if statement, so this is what should be executed if this function gets called, and if the sky is equal to clear, well then this line is indented twice. And that is the equivalent of 4 spaces in our code, like this. Now, every time I've talked about indentation, I've been talking about spaces. And actually, there's 2 ways of creating indentation. You don't have to just use spaces. You can also use tabs. And that's created using the tab key on your keyboard, which can look a little bit like this. Now, there's a lot of debate around spaces and tabs, where some people prefer using spaces to indent, other people prefer tabs to indent, and there's a lot of people arguing in the coding community. And I think this excerpt from one of my favorite shows really demonstrates this.
Richard, what's wrong?
Nothing. Nothing. Literally, it's all good. Come on.
Oh my God.
I'm sorry.
Your roommates were right. You really hate spaces.
No. I don't. It's not hate. Hate's a strong word. Truth be told, I do have a slight preference for tabs, but that's only because I'm anal and because I prefer precision.
Well, not to pick a fight here, but if you really care about precision, wouldn't you use spaces? But whatever. Once it goes through the compiler, it's the same thing, right?
Yeah, technically, yes. I guess I just don't understand why anyone would use spaces over tabs. Like, if it's all the same, well, why not just use tabs?
Because it could look different on other people's computers.
Tabs create smaller file sizes, all right? I run a compression company. Trust me, I've devoted my life to minimalizing file sizes. It's what I do. I mean, I do not get why anyone would use spaces over tabs. I mean, why not just use Vim over Emacs?
I do use Vim over Emacs.
Oh, God help us. Okay, you know what? I don't think this is gonna work. I'm so sorry. I mean, like, what? We're gonna bring kids into this world with that over their heads? That's not really fair to them, don't you think?
Kids? We haven't even slept together.
And guess what? It's never gonna happen now because there's no way I'm gonna be with someone who uses spaces over tabs.
So should you be using spaces or should you be using tabs? The age-old question. And the extent to which people obsess over this question really shows in this 2017 Stack Overflow developer survey, where they asked the developers, do you use spaces or do you use tabs? And then they compared it against their annual salary and somehow have managed to show that the people who use spaces seem to earn a lot more than the people who use tabs. Now, the official guide from the Python community is in fact to use spaces. So if you click on this section, tabs or spaces, they tell you in no uncertain words that spaces are the preferred indentation method. And in fact, in Python 3, you can't mix a code file that uses tabs and spaces for indentation in the same file. And it also tells you that in order to indent a line of code, it should be indented using 4 spaces. So 4 hits of the spacebar. Now, for a lot of people, that may seem quite inefficient because I have to hit my spacebar 4 times in order to achieve a single indent. And you've seen how much we indent throughout our code. So it seems very, very inefficient. But luckily, in most code editors, they actually have a setting that allows you to indent using spaces, changing the indent size to 4. And when you hit the tab key, it will automatically insert 4 spaces, which you can tell when you're trying to highlight this space. You can see the cursor is jumping 4 times. This means that you get to hit tab once and that your code is in line with the guidance, because behind the scenes, your code editor is inserting 4 spaces. So I hope that clears up a little bit on tabs versus spaces, and I highly recommend you to head over to the course resources and click on the link to go to the style guide for Python code and take a look through the parts about indentation. Now, in the next lesson, I've got a quick quiz for you to test your knowledge on indentation. So for all of that and more, I'll see you on the next lesson. All right, guys, in this lesson, I want to talk about the while loop, the loop that will continue going while a particular condition is true. This is a really simple version of a robot that's using a while loop. So in this case, the instruction would be while you are plugged into the wall and you have electricity, move forwards. So this is what happens. It will stop once it pulls the socket out of the wall and it stops receiving electricity. Let's compare this against the for loop that we've seen before. So we've seen sort of 2 flavors of the for loop. One where we're looping through a list of items to do something with each item in the list. And the other is using a range function where we create a range between A and B, and then we use every number in that range to do something. For example, in this case, would be to print it out. The while loop looks something like this. And in this case, while this particular condition is true, then we go inside the loop and we do something repeatedly. And it's only when this something becomes false does the loop stop. So let's take a look at what the code would look like in real life. So here I have the hurdle 1 challenge that you did previously. And for this, we created a for loop in order to get our robot to jump over the hurdles 6 times to get to the final destination. Now, we could also do the same thing, but using a while loop. And this is how we would do it. Let's say we create a variable called number of hurdles, and we set that equal to 6 because there are 6 hurdles. And then we use a while loop to loop through these hurdles until this goes down to 0. So we could say while number of hurdles is greater than 0, colon, and then we get it to do something. Well, in this case, what we need it to do is to perform the jump function. And at the end of the loop, just before we go back to the beginning, we're going to decrease the number of hurdles by 1. So minus equal 1. So now let's go ahead and delete this version using the for loop. And in order to better visualize what's happening here, I'm actually also going to add a print statement to print that variable. So now let's step through this And the first time we enter the while loop, number of hurdles equals 6, 6 is greater than 0, then that is a go-ahead to jump into the loop and execute these 3 lines of code. So now we go in and it performs the jump function. And then once that's done, it comes back, goes on to the next line. Number of hurdles minus equals 1, so 6 should become 5. So now when it executes this print function, we should see 5 printed. So let's move this little pop-up away on the side and let's keep going. So now it's gone back to the beginning of the while loop and it's testing this condition once more. Is the number of hurdles, 5, still greater than 0? Well, so if it's true, then it goes into the while loop again and performs all of those lines of code. So now it's minus 1 and it should now be 4, and it keeps on going until the point where this condition, number of hurdles greater than 0, becomes false. So now this is the moment where we're going to subtract a further 1 from our number of hurdles, which is currently 1. So that should take it down to 0. And once that's done, this condition is no longer true. 0 is not greater than 0. 0 is equal to 0, but it's not greater. So now this is false, and we exit out of the while loop and we end our program. This is what the syntax for the while loop looks like. First, we have the while keyword. And then we have some sort of condition that we're going to test. So previously you saw it was number of hurdles being greater than 0. And whenever that condition is true, then it's going to look inside the while loop at the indented lines of code to carry out those instructions, to do this, then do this, then do this. And finally, when it gets to the end of the while loop, it comes back to the beginning and tests this condition again. And if it's still true, then it's going to go through and loop and loop and loop until this condition becomes false, at which point it ends and exits the while loop. So now coming back to our Reborg's world, I want you to click on this drop down and go to hurdle number 2. Now this is a little bit different, and if you want to see the explanation for this exercise, then simply just click on this world info and you'll see the explanation. So essentially, this hurdles race is a little bit different from the last one. Whereas the last one, we knew that we had to always complete 6 hurdles to get to the goalpost. In this case, we no longer know where the flag is going to be. So it could be here, it could be here, it could be here, etc. And it's going to be set randomly to one of these positions. But what we now get is some sort of condition called at goal. And if this at goal is true, then it means our robot has landed on a flag. But if this at goal is not true, then it means that it's not yet reached the flag. So we can use our knowledge of while loops as well as this condition to use our code that we had from previously to get our robot to complete this hurdle race. So you should still have the code from the previous challenge up, and all you have to do is to think about how you would create a while loop so that when you run this program and the flag is set randomly, so this time it was set to be here, but the next time I run it, you can see it's now set here. It doesn't matter where the flag is, your robot should be able to detect if it's at a flag, if it's at the goal, and if it's not, then it should continue jumping. Pause the video quickly and see if you can complete this challenge, and then come back and we'll walk through the solution together. Alright, so the first things first, we know that we're going to need to use a while loop. And the condition that we're going to be testing for is this one, at goal. This condition can be true or it can be false. And basically, we're looking to see while at goal is not equal to true. So while our robot is not at the goal, then we want to perform the jump function. So we're going to jump for as many times as is required until this at goal becomes true. Another way of expressing this at goal is not true is to say while not at goal. So this is what they mean by the negation of this condition. Either way of testing this will work. And now if I hit run, you can see that even though we only need to perform one hurdle, as soon as our robot gets here and it checks that at goal is true, then it will stop this loop. But if our loop goes on for much longer, say the goal is over here, then once it reaches here and at goal is still false, then it's going to continue jumping until at goal becomes true. So that required a little bit of mental jujitsu, I think, because this entire condition has to be true, but this at goal is actually going to be false until the moment where we reach the goal. So by adding this not, we effectively flip this at goal. So if it was true, it becomes false. If it's false, it becomes true, in order to continue jumping while we're not at the goal. I prefer this particular type of syntax because it reads more like English. While not at goal, then perform jump. And if it is at goal, then it will stop. And one of the things you might be wondering right now is, so I've learned about the for loop and I've learned about a while loop, and if I can use both of them, why would I choose one over the other? When would I use a for loop and when would I use a while loop? Well, what I would tend to say is that for loops are really great when you want to iterate over something and you need to do something with each thing that you're iterating over. So, for example, if you're iterating through a list and you're saying for each fruit in our list of fruits, and you want to be able to say, I don't know, do something with each of these items in here. For instance, it can be as simple as just printing it. Well, then this will require a for loop. You can't do this very easily using a while loop. Now, similarly, we've used the range function, right? So for range from 1 to 6, print each number in the range. Well, this is also easier to do with a for loop. Now, you want to be using a while loop when you don't really care what number in a sequence you're in, which item you're iterating through in a list, and you just simply want to carry out some sort of functionality many, many times until some sort of condition that you set. And this is also a good point to mention that while loops are a little bit more dangerous than for loops. Because in for loops, you're setting ahead of time how many times something is going to run. It's going to stop once it reaches the end of the list of items in this case, and it's going to stop once it reaches the upper bound of the range in this case. But for while loops, they will continue running until this particular condition switches to false. So if you have some sort of condition that actually never becomes false, well then your while loop becomes something known as an infinite loop. Because let's say that our while loop tested while 5 is greater than 3, then carry out these 3 lines of code. Well, 5 is always going to be larger than 3. Until the end of time. And so that means your code is also going to run until the end of time, which is probably not what you want in most cases. If instead of saying while not at goal, I said while 5 is greater than 3, then you're going to see this robot perform this jump until eternity. And it's basically going to stop only once it's crashed and it's timed out. Now, every single programmer at some point in their lives will create an infinite loop. Don't worry about it, just quit the program, restart, and try to prevent this from happening in the future. And very often I find that it's really helpful when you don't know why you're getting an infinite loop to simply just print out your condition. So in this case, if I printed out 5 greater than 3, then it's always going to print true. And it's never going to become false, basically. In the next lesson, I've got more exercises coming up for you, namely hurdles 3 and 4. So head over there and put what you've learned about while loops into practice. Alright guys, it's time for yet another coding challenge, and this coding challenge is going to put into use what you've learned about while loops, while also testing some of the previous knowledge you got on functions. So I want you to head back to Reborg's world and change to hurdle number 3 and take a look at the premise for this particular race. Essentially, what's happened this time is that the wall placement has become random. So let's say we restart this game. You can see that in this case, there's a wall here, one here, one here, one here. There's 4 in total. But if we try a different version, then you can see that there is different wall placement each time. Not only do we know where the wall is going to be, we also don't know how many walls there will be. So code such as what we did before using a for loop telling our robot to jump 6 times is not going to work. And instead, we're going to have to use the conditions whether if front is clear, or whether if there's a wall in front, or whether if we're at the goal, and also their negations. So not front is clear, not wall in front, not at goal. See if you can use what you've learned about while loops, as well as your previous knowledge on if statements and functions to complete this challenge. When you have written the correct code, no matter what kind of wall situation or hurdle setup they have, it should always be able to get to the goal. And while I've been looking at this challenge, I know there is a very, very simple way of bypassing this challenge, which is simply to get the robot to go up here and all the way down here, going past all the hurdles. But that's not the point of the challenge. In order to complete this challenge, you must get your robot to follow the path that's set out in the dotted lines, instead of bypassing it and doing something completely different just to get to the final goal. Pause the video, have a think about this, have a read of the world info pop up here, and then think about how you can solve this challenge. So give it a go now. Alright, so essentially, if we don't know where the walls are going to be, then we have to test to see if there is a wall in front or if there is no wall in front. And if there is a wall in front, then we're going to jump, but if there's no wall in front, then we're just going to move forwards. And we're going to do this and test this for as long as we're not at the goal. So we're going to need a while loop that's very similar to our previous while loop that I showed you in the demo. While we're not at goal, or rather while this particular condition is not true, then we're going to repeat and loop some lines of code. The first thing we're going to do is we're going to use an if statement to check whether if there is a wall in front. So I'm going to say if wall in front. If this is true, then I'm going to perform the jump function and get it to jump over the wall. But if there is no wall in front, so namely else, well, in this case, we're simply just going to move forwards. And because our jump function is always going to get us to face the right way, which is this direction here towards the goal, then this move forwards by 1 function is always going to take us in this direction. So let's take a look at this code and let's step through it step by step. So the first thing we're going to check is, are we at the goal? At goal is going to be false, so not false is going to be true. So while this condition is true, we're going to carry out all the lines of code inside. So that means we should jump into this if statement and check, is there a wall in front? So at this point, this should be false because there is nothing in front. So it should bypass the if statement and it should go to the else statement, in which case it should move forward by 1 step. So that's the end of one loop, and we go back to the beginning. Are we at the goal yet? Nope, we are not. But now when we run into our if statement, this check should now come up as true because there is a wall right in front of our robot. So in this case, it's going to go into the if statement and perform the jump function. Now, our jump function that we defined previously actually gets us to move forwards by one step first before we actually hurdle over this wall. So in this case, if we try to do the same thing, then it's actually going to hit our robot into a wall. We have to modify our jump function by removing this first move function. So instead, we get it to just turn left, go up, turn right, turn right, go down, and then turn left to face the right direction. This is a pure hurdle without that extra step in the beginning. And instead, we're going to only move if there is no wall in front. So we've changed the code. Let's back it up and try this again with a different setup. And in this case, you can see as my code is going through the different steps, it's checking to see if there's a wall in front. If there is, then it's going to jump over it. If there isn't, it's just going to move forwards by one step, and then it's going to reevaluate. So this way, once it gets to here, it's actually going to reevaluate the while loop quite a few times, and every time it's going to be the else statement that fires. It's going to move until it hits a wall again, and then it's going to jump over and take us to the finishing line. Did you manage to get this correct? Did you manage to get the solution right? If not, be sure to review the previous lessons on the while loop so that you familiarize yourself with it. And also, if you got stuck on changing the jump function, then be sure to remember that whenever you get stuck, it's important to test your assumptions. And in this case, you could have pressed the step through button many times to see which line of code is being triggered at which point and which is the moment where our code actually fails, so you can figure it out and fix it. Now, on the next lesson, I've got yet another code challenge for you, so head over there and give it a go. All right, guys, it's time for the final hurdle before we get to our goalpost. In this lesson, I want you to switch over to the final hurdle challenge, which is hurdle 4. And in this particular version of the hurdle, the wall that the robot has to jump over to now has a variable height. So the height of each of these hurdles is completely random. The position of the hurdles are random, and also the number of hurdles is also going to be random. You can see that every single time that this regenerates, it comes up with a completely different set of hurdle profiles. And now we can't just jump because we don't know what the height will be each time. So we have to use what we've learned about while loops to modify this jump function and see if we can get the jump to jump as high as necessary depending on the height of these walls. Just as a reminder, in order to complete this challenge, you should take a look at the Rebor's keyboard window and go to this tab called Conditions and see that you can check if the front of the robot is clear, if its right is clear, if there's a wall on the front, if there's a wall on the right, and various other things. The ones that are probably going to be the most useful is this top row here. So we want you to take a look at these conditions, see how they're spelt and how you can use them, and then try to use them and test them out using your Reborg robot. Now the goal is of course to reach this final flag, going over various hurdles using this dotted line as the path, which is going to be different each time. Just as a head up, this is going to require you to modify this jump function, have a serious think about it because it's not easy, and you're going to need to use more while loops to achieve this and outcome, and try to see if you can solve this challenge in the least lines of code possible. So I managed to do it in as little as 24 lines of code, so see if you can aim to achieve that. Pause the video now and give this challenge a go. Alright, so the key difference between this particular hurdle and the previous version is that the height of the wall is now random. Instead of just jumping over one square where we turn left, move, turn right, move, we have to now see if the right side has a wall or if it's completely clear. Now, in this case, what I want to happen is I want to turn my robot to the left first of all, and then I want to check if there is a wall on the right. So I can use this condition, wall on right, to achieve this. And if that is true, then I want to continue moving forwards until there is no longer a wall on the right, in which case I'm going to turn right, and then start going down. So let's modify this jump function. We definitely need the robot to turn left, but after it turns left, we're going to use a while loop to say that while there is a wall on the right, then in this case, we're going to move forwards. So we're going to go up in this direction basically because we've turned left already. Let's test this out and let's run this code. You can see in this version of events, my robot is going to keep going until the very end of the screen. This is not what we want. So what we want to do is when this is no longer true, it's going to skip to line 10. So at this point, there is no longer a wall on the right, because otherwise it would have continued looping and calling this line 9 where it gets it to move forwards. When there's no longer a wall on the right, then we want to do what we did previously, which is to get our robot to turn right, move, and then turn right. Now at this point, we have to move down the wall, and what we're going to check is whether if the front is clear, because it's only when we reach the very bottom here, when the front is blocked, do we actually turn left again and continue back to our while loop here to move forwards. To do this, we're going to add yet another while loop. And in this case, we're going to use the front is clear condition. While the front is clear, we're going to get the robot to continue moving forwards. So once it's turned to face this direction and there's no wall in front, it's going to keep going until this is no longer true. And that is the end of our jump. So now we've basically modified this jump function to take into account all of these new things, such as while there's a wall on the right, then continue moving upwards. While the front is clear when it's coming down, then continue moving downwards. And then at the very end, we're going to get our robot to turn left, so that we're ready to go and check if we're at the goal. And if we're not at the goal, then we're going to check if there's a wall in front. If there is a wall in front, then we're going to jump. Otherwise, we're going to continue moving forwards, or rather to the right, to get to the goal. So now this is the final code. And depending on the number of spaces you've added in here, obviously it's a little bit easier to read if you actually have it like this. But depending on how you've spaced things out in your code, you should end up with anywhere between, say, 20 to 24 lines of code. So I want you to be able to see all of these lines of code on the right when we run this code. And I've actually got a typo in here that it's going to tell me. So it's going to say invalid syntax, and the problem is just because I forgot a colon here. If you get that pop-up invalid syntax, be sure to check if you have any problems in here. And it can get a little bit complicated if you leave your code for a long period of time before you test it. So test your code after every little iteration, and then when you actually get something like an invalid syntax, you'll be able to catch it more easily. So now let's go ahead and regenerate our map, and let's try again. So when we're going to make a jump, and then we're going to turn right, and we're going to keep going down until we hit the wall or we turn left. And now we're not at the goal and there's still a wall in front, so we make another jump and we go down this much, much larger wall. And then we continue this process of using several while loops, checking if there's a wall on the right, checking if the front is clear, checking if there's a wall in the front, in order to achieve our goal and get to our final destination. Now, for your code to successfully complete this challenge, the line that your robot draws should follow the line that's dotted here, just like what you see here. So instead of going just over the top and getting to the final goal, it should follow each of these steps, and finally you should get that green pop-up where it says it's at the right position. So did you manage to complete this challenge? If not, be sure to review the lesson on while loops and just have a play around with while loops. Try some of the different conditions and see what happens when you run the code and see how the robot behaves so that you get a good grasp of how these things actually work. Now, on the next lesson is our final project, and we're going to get our robot to be able to navigate a maze all by itself using what we've learned, including functions as well as while loops, as well as using good indentation. So for all of that and more, I'll see you on the next lesson. All right, guys, it's time for the final project of today. And the goal is to be able to write some code here in Reborg's world to be able to get our little robot to be able to navigate to the goal and go through a maze no matter what the maze looks like. So if you go back to Reborg's world, if you already got a link open, if you don't, then simply click on the direct link in the course resources and it should take you here. And we've got the maze selected in the drop down, which is right here. Here we have a maze. And even though the maze doesn't change, the robot does. The direction that the robot is going to face is completely random. The position of the robot is also random. So you can see every time I restart the game, it will face a different direction. So in this case, it's facing up, but the next time it might be facing down in this case. And it's also always going to start at a random location in the maze. If you click on the world info, it'll tell you that the secret to getting the robot to complete the maze is to get it to follow along the right edge of the maze. If it starts anywhere in the maze and it just continue following along the right wall, it should eventually get to the final destination. For example, like this. Now, in this case, the robot is not making a beeline straight to the exit as if it could see what we can see, but it is following a strategy, or rather what you would call in programming an algorithm. And the algorithm here is to simply follow along the right edge of the wall, and if the right side is clear, then continue going right until it's no longer clear, at which point it should just go straight. And if you can't go straight and you can't go right, then the last option is to turn left. It's almost like the robot is getting a set of instructions in terms of hierarchy. The most important, telling it to turn right if it can. If it can't turn right, then go straight ahead. And finally, if it can't turn right or go straight ahead, then to turn left as a last resort. So you're going to need to use a lot of the functions that you saw previously, such as move, turn left, and testing whether if the front is clear or the right is clear, or there's a wall in the front or wall in the right, and whether if the robot is at the goal. Think about how you can use a while loop and also the conditional if, elif, else statements to achieve this goal and get our robot to be able to go to the final destination no matter where it starts out and what direction it's facing. Pause the video now and try to use what you've learned to complete this final project. All right, so did you manage to complete this challenge? If not, let's work through the solution together. The first thing we need to do, which we've always pretty much needed completing each of these challenges, is we need a way to turn right. So I'm not going to type it all out again. This should be already pretty clear. Turn right is just turning left 3 times. Now, the next thing we need to do is we need to tell the robot to do things and to check for things until it reaches the goal. We know that we have this test called at goal, so we can use a while loop to get the robot to continue working until it reaches the goal. To define that, we could say while not at goal. So basically keep repeating the instructions inside this while loop until at goal becomes true and not true is false. So once this condition becomes false, then our while loop stops. So what we were told in the world info is we should follow along the right edge. We should test to see if the right side is clear, and if it is, then we should turn right and go straight. So that basically means moving right. Let's use an if statement to test if right is clear. And in this instance, so in this if block, we're going to say, well, turn right using our pre-built function up here. And then once you're facing the right, then move forwards. This should achieve a right move. So from here to here, for example. Now let's test this and see what happens. In this case, the right is clear, so it moved right. The right is not clear, so it doesn't know what else to do, and it's now stuck in what we would call an infinite loop. And it will never stop until the browser actually forces it to by crashing. So what we have to do instead is we have to provide an alternative condition. When the right is not clear, what should it do? So we're going to provide that condition by using an elif statement. And what we want to say is, if the right is not clear, well then maybe you should check if the front is clear. And if that is the case, then simply just move forwards. Now, this would work unless we're in the situation that we're in right now, where we're boxed in and the only side that's clear is actually the remaining one, which is the left. That's why we have to put in the last line of code, which is going to be an else statement. So in all other conditions, when the right is not clear and the front is not clear, so once both of these have been checked and they're false, then actually just turn left. So now you can see that when our robot is able to go right, it will try to follow along the right wall, but when it can't go right, it'll go forwards instead. And when it can't go right or go forwards, then it's going to turn left, and hopefully the next time it checks the loop, the front will be clear and it will be able to move forwards. So notice how our robot is somewhat haphazardly navigating through this maze, but it is following the algorithm that we specified, which is to follow along the right-handed wall until you reach the goal. And that's what these few lines of code does using our while statements, our if, elif, else statements, and also our turn right function. Now, while everything seems to work all right, there are select cases where the robot might start at a position and face a particular direction that gets the robot into an endless loop. So here's an example. Let's say the robot starts off at this particular position facing down. If we go ahead and let the robot run the code, you can see that firstly, there's over 1,000 steps in the code. And what happens is, because the robot doesn't have a wall on its right, it's going to keep looping through this circle. Because after all, we're telling it, if your right side is clear, turn right and then move. And the right is always clear when it's inside this boundary box. So depending on where the robot starts out, it might get itself into what we call an infinite loop, because you can see the code just goes again and again through this while statement, and the robot's never going to be able to escape from this position. So this is one of the things that happens to your programs. Sometimes there are edge cases which you might not have thought of, but it's only through testing the code do you discover them. Now, this particular issue, I would say, is more of an intermediate debugging problem. So if you're somebody who's already really comfortable with Python and you want to try out debugging this particular problem, then I've included some problem worlds for you to test your code against. Now, if you are somebody who is still getting to grips with Python, I would say this is not the right time point to tackle this challenge, and I would go ahead and make a note to yourself that once you've completed day 15, and you're firmly within the intermediate territory of Python, to come back to this problem and to continue to debug this particular edge case. Now, if you are a beginner, I recommend to skip the rest of the video, but make a bookmark and make a note here so that you know to come back. Now, if you are more of an intermediate programmer, then let's go ahead and debug this. So what you can do with Reborg's World is you can actually create a file to load up a particular map and robot position. So what I've done is I've created a bunch of problem worlds for you to test your code against, that we know if you use normal code, it's definitely going to get into an infinite loop. So what you need to do is head to the course resources for this lesson and then download the zip file, which contains 3 problem worlds for you to test your code against. And then in Reborg's World, you're going to click on Additional Options, Open World from File, and you're going to select that folder, which hopefully you've unzipped, and go through each of these problem worlds, testing your code in all of the cases. Now, when you open this up, you can close off this box and the robot will start at a particular problem position, facing a direction that is going to cause it to go into an infinite loop. And you can know this ahead of time because when you actually go to start the robot and you hit play, when you can see the number of steps here over 1,000, it usually means that you're probably in a situation where it's going to turn into an infinite loop. So write your code here and then test it to make sure that the step count goes down below 1,000 and your robot doesn't get stuck in this endless circle. Now, because the different problem worlds can have different solutions, but what you're aiming for is one solution code that solves all of the problem worlds, I want you to test your code against all 3 of these problem worlds I've created for you. So here's the time, if you want to tackle this challenge, to go ahead and pause the video and see if you can debug this pretty hard problem. It took me a while, so I think it's going to take you a while as well, but you might be smarter, it might take less time. So good luck, pause the video, and we'll go through the solution together a little bit later on. Alright, so first let's try and figure out what the problem is. The problem here is that every time when the robot's right side is clear, our code tells it to turn to that direction, move forwards, and then check to see if it's at the goal. So it's not, and then again the right side is clear, so it turns right and moves, turns right and moves, turns right and moves. So basically in any of these 4 positions, depending on the way it's facing, there might not be a wall on the right side of the robot. So that is the key to solving this bug. We have to get our robot to a starting position where it has a wall on the right side of the robot. Now, I've been thinking about various ways of doing this, and the shortest, most succinct way that's also most understandable, I think, is this. So if we create another while loop before this while loop runs, so remember the code goes from top to bottom, it's going to hit this while loop first. And we check while the front is clear, well then the robot is not next to a wall, right? Such as in this case. Well, if that is the case, we're going to tell our robot to just move forwards. So this means that our robot is going to seek out a wall. So in this case, for example, it's going to go forwards until it reaches a wall. So it's going to loop through that loop twice, and it moves twice until it hits a wall in front. Now this is the point which we want, because we want to make sure that now that it's hit a wall in front, that it's definitely got a wall on the right side of the robot. So what do? Well, once it's hit a wall, so it's exited this while loop, we're going to tell it to turn left. So this loop makes sure that the robot has a wall in front of it, and once it's found a wall in front, we tell it to turn left to turn that wall onto the right side of the robot. So now you can see we're going through this while loop. First, front is clear, so it's going to move. And then front is still clear after that one move, so it's going to move again until it's hit a wall in front. Now at this point it exits the while loop and it goes to the next line of instruction, which tells it to turn left. Now that the robot has turned left, it now has a wall on the right side and it enters the next loop. So in this loop, if the right side is clear, turn right and move. If the front is clear, just simply move forwards. Otherwise, turn left. So as long as the robot starts at a position where there is a wall on the right side of it, right next to it, it's never going to get into that infinite loop with this code. So this is one solution to this problem. Now, there's lots of other solutions, but what you got to make sure is that your solution works in every single one of these test cases. So we can go ahead and open up problem world 2, where the robot starts at a different position, facing a different position, and we want to make sure that still we don't have an infinite loop. In this case, it doesn't, so that's great. And finally, let's test the last one, which is problem world 3. And now we can run our program, and you can see it's also less than 1,000 steps, so it works. So this is a bit of advanced debugging because we're now testing our code against various terrible scenarios where the robot starts off at a position where it's really dangerous and can get into these infinite loops. Now, if you didn't manage to get the solution, don't despair and don't be too hard on yourself. This is a really hard one, and it took me a long time to find a solution that I think is readable and explainable and sort of makes sense. Now, it might be that you should put in a note in your calendar to come and revisit this issue in a week once you've had some time to think about it and to really digest and understand this solution. Then try to write the code yourself, because you will have forgotten exactly what the code was, but you'll still remember how it works. So if that is the case, this is what you should do. If you solved it by yourself, then congratulations. This is really, truly quite a difficult task.
Hey, well done for completing day 6. Now, I remember back when I was learning how to windsurf, just how hard learning a new skill can be. And I think when you become an adult, this is like a really unfamiliar sensation, learning something new. Because more often than not, you're probably working in a job that you've done for years. You've probably gotten really good at it. And you haven't actually needed to struggle to really feel the pain that you feel with learning. And this might be the first time you're doing that for a while. So just as when you get onto a windsurf board and you hit the water a few times really painfully, I just hit my face so many times that you feel like this is too hard. But actually, the struggle is necessary. The more you struggle, the more you're learning. So don't interpret the struggle as a bad thing. It's a good thing. It means that you're making progress. So keep going, and I'll keep practicing my hat tricks.